Yes. Okay, so everything is okay. I already started the streaming. And let me remove this. And we'll start with the tutorial, the solutions of the tutorial 6. This is not it. Here. So let me run this cell just to remove the warnings. So if you remember last tutorial, we saw the example about the electrocardiogram. And basically, all of you got the solution right. You could make a filter with 100 or 150 zeros, and you need to divide by the number of components of the filter, so it will do an average or a moving average. And you just call the function convolve with the signal and the filter. Just to remember you, it's very important to use the mode same, because if you do not do that, the resulting signal will not have the same size as the original signal. Okay, but this is an example of how to do it. You could do it beta or with another more complicated filter, but this already solves the question. Okay, so the second part that is not showing, let me fix that quickly, was about doing the Haar wavelet, or the Haar wavelet transform, that if you remember was just applying 4 different filters, doing a downsampling of the images, the resulting images, and then concatenate all the results to obtain the wavelet transform. So basically, how do you do that? You import the image, you transform it to a black and white image. You can do it also with an RGB image, but it's easier just to do it as a black and white image. And you apply 4 filters. The first one is the low pass filter that just do an average, a moving average. Then you have a filter that does a low pass filter in one direction but a high pass filter in the other. This is the transpose filter, the transpose filter of this one. And the last one is applying a high pass filter in both directions. And here you see the results. When you just apply the low pass filter in both directions, you will see the image a little bit blurred. Then you can see the differences or the edges in this direction, and with this one you can see the edges in this direction, and this you can see it in the diagonal direction. That's the first part, and then you need to concatenate the results and downsample them, and you obtain what is shown here, that is the Haar wavelet transform. In here, after applying noise, because one part of the question was apply noise to this image and try to denoise it using the soft thresholding. So the soft thresholding is this one here, and if you move the parameter lambda, that is the cutoff of the threshold, you can see that if this is your input and this is your output, if your input is well after the threshold, that is in this case is 0.8, you'll obtain a value, but if it's within the range of plus minus the threshold, you obtain 0. Obviously if the threshold is 0, you are not filtering anything, and as you move the thresholding, you start filtering the coefficients with lower values. And the implementation of this soft thresholding in Python can be done with this function here just in one line. It's a very easy function to do with NumPy. Okay, and the solution of the whole question, I let it as a homework, because it's just applying this filter here to a noisy image and going back. So try to do that, and we'll start with the with the tutorial 7 about convex optimization, and in particular the CVXPY package. But before starting this part, do you have any more doubts about the previous activities or something like that? Pablo is talking about the second homework. Yes, if you have any question about the second homework, try to do it via Canvas. Any other question about the what we saw in the previous section here? If no one talks, I'll start asking people. Victor, did you get what the hard wavelet transform was doing?
No, because I read it something wrong, so I'm checking again.
What did you say, that you arrived now or what? Later?
No, I read something wrong, so now I'm looking what was my mistake.
Okay. Well, let's just start with the convex optimization part of the tutorial then. And for this, let me put it in full screen. I'll start describing what CVX Python is. Has some of your used CVX, but not the Python version? Has any of you used it?
No, for me.
No?
Never.
No.
Okay, so
I've never seen that combination of letters before.
okay, so that's the okay. So this is new for you then, but CVX without the pi is a package written in MATLAB to do convex optimization, written by some people in Stanford. And one of the PhD students of that professor did the Python version. And basically, what is the difference between CVX Python and other optimization packages or algorithms? Is that you can write the mathematics of the problem. For example, if you have a minimization problem, you almost write minimize and and you write the problem how you would do it mathematically, and then you just put solve. In other packages, you need to write the inputs in a specific way and then try to solve. Here is what the CVX packages in general, what they try to do is to remove the gap between the application and the mathematical formulation. Here you almost write exactly the mathematical formulation of the problem, and it makes it a lot easier to implement. And CVXPy is just the Python version of CVX. One important thing in CVXPy is that you have three main objects. The variable object, that obviously is used to define your optimization variables. This is this will be the variables that you will move to optimize the problem. Then you have a minimize object in which you put a function to minimize, and the problem formulation that has the optimization function here with minimize, and also the constraints. Well, today we'll not be seeing a lot of problems with constraints because that will be the topic of the next TA. But here I'm putting a very simple example that has all the elements of the CVXPy package. And as you can see here, we can define x and y as variables. Then, just by writing two constraints, like x plus y equals to 1 and x minus y greater or equal than 1, and you just put minimize x minus y, that's your objective function. Then you put those ingredients, the constraints and the objective function, to the problem object, and you then put the well, you just solve the problem. In the latter slides, I will be talking about how to know if the problem was indeed solved. But here you can see that the solution, or the obtained optimal solution for for x and y, is, for example, x equals to 1 and y equals to 0. I'll just run it again to demonstrate that it works. And is as easy as that. You just write the mathematical formulation of the problem and then use the solve function on the problem object.
Carlos?
Yeah, Carlos?
Yeah, so this CVXPY, it can solve non-linear problems from what I'm seeing over there in the minimize function.
Yes,
Can it accept non-linear constraints as well?
It can solve a lot of optimization functions and constraints while the problem is convex. So it could be however you want. Meanwhile, the problem is still convex because this package is made for convex optimization, but the constraints and the minimization problem can be very difficult or very complicated. In an example, we'll see in the activity 1, we'll use an optimization function that is the logarithm of whatever, so you'll see that that works as well.
Nice, thanks.
Okay, so one thing that is useful to know is that if the optimization algorithm actually found the solution, because you could run an optimization algorithm and just fail to find a solution. And that could be because, one, the number of iterations, for example, was not big enough and it didn't converge to the solution. Or it could be a problem with the problem. The problem could be unfeasible. For example, trying to find something in a space that is, for example, an empty set. Here we can see two examples when the problem is unfeasible or infeasible. And basically, if you minimize x, x is a linear function. And if you use the restrictions x greater than 1, greater or equal than 1, and less than 0, less or equal than 0, the constraints are describing a space that is equal to the empty space. Therefore, this problem does not have a solution. And if you use the problem solve, it will give you that the value is equal to infinity and the status is infeasible. That means that the optimization problem does not have a solution. Other thing that could happen is that if you minimize the same function but you don't put a restriction or constraint, basically the minimization of x is unbounded because you can go to minus infinity and you will never find a minimum value. And in this case, the status is unbounded because you can go down and down to the optimization problem and you will never find a solution. And as you can see, if you run the code, if you see the variables problem status, it will say infeasible and unbounded. And obviously, if the problem was correctly solved, it will say solved or something like that. Let's check that. For example, here, problem.status. If you run that, you'll see that here the status is optimal. That means that the solution is correct, or that the algorithm found the optimal solution. Okay. Another very interesting thing with this package is that you can define scalars, vectors, or matrices with numpy arrays, or however you want. But for defining a variable as a vector or as a matrix, here you can define the size of the variable with the numbers inside the variable object, or the constructor of the variable object. If you just put 5, it will by default just do a vector with 5 components. If you put 5, 1, is a vector with 5 and 1 dimension. That is not exactly the same as just 5 and comma, but in a lot of applications it will be the same. And last, you have a matrix here, and you define 4, 7, and you define the first dimension and the second dimension. That's very obvious to define a matrix and a vector in CVXPY. And as I was saying, to define operations with these variables, you can use numpy arrays. For example, if you want to multiply this x by a matrix, you can define the matrix as a numpy array and use the, for example, the add multiplication, like that. So let's say A is a numpy array and X is a variable object in CVX. You can multiply them as you would do with regular numpy arrays with the add symbol. Okay, so now we'll see an example of an optimization problem. Here we can see that, for example, in this problem, we have a mass spring system that is in a rail with no friction. And the potential energy of the string can be defined as 1/2 the string the spring constant times x squared, where x squared is the distance between the actual position of the object with the resting or on a stretch length of the spring. In this case is defined just as x equals to 0. And to find the equilibria of this mechanical system, if you have the energy, you can see that there's a minimum. And basically, if you try to minimize the energy in a mechanical system, you'll find the equilibrium point of the system. In this case, this energy is just a parabola, so you know that in the center you'll have the minimum of that parabola, and that's obviously x equals to 0. So that means that the equilibrium position of the system with a mass and a spring is the position in which the mass is at the unstretched length of the spring. That is very intuitive. Okay, so now we'll do an activity in which you will start programming in CVX Python. And as I already said, we'll see a very complicated problem. Well, the problem here is related with backflips and the logistic regression. We'll try to predict if a person can do a backflip or not based on the number of hours he has trained. Okay, that will be our variable, the number of hours of training, and then the variable we want to predict would be if he or she can do a backflip. And we'll do that with the logistic regression, and the logistic regression is commonly used in machine learning to model a probability of belonging to a class. In this case, the class is it cannot do a backflip, or yes, it can do a backflip. So you have two classes, the backflip class and the boring class, okay? And basically you're modeling the probability of belonging to the backflip class or whatever. And this u is the characteristic that we'll be using, that in this case will be the number of hours of practice. And we want to find the parameters a and b. And as you can see here, the optimization problem is very complicated. It has a logarithm of an exponential, but this is a convex problem, so we can solve it with CVXPY. And as a hint, you need to do something similar of what you've learned with the linear regression problem that we've done previously. And also, just as a hint, you need to use the log sum x function that basically does the summation of logarithms of an exponential. You can see what it does with the documentation. And your data will be this one here. Basically, you can see that your variable u is the number of hours an individual has trained, and the other variable y is if you can do a backflip or not. And each of these points is a person. For example, all the persons or all the people that has trained more than 6 hours is almost all in the backflip class, okay? But if you don't train, you cannot possibly do a backflip. So you see the people here that cannot do a backflip. Okay, so that will be the activity now. Let's break the rooms as is usual.
Oh, sorry, we have to fit in the code. We have to fill in the gap between plot and the defined terms. Yeah.
Sorry, can you repeat the question?
Yeah, in terms of like what we have to do in the task, like we just add to the code that's already been made, like between everything defined and the plot, we have to just add stuff in the middle.
Not exactly. What you need to do is solve this optimization problem. So for that you need to do first to define a variable. In this case will be a and b. Then you need to define the minimization object that will be this one here, and then define the problem. Here you don't have any constraint, so only the minimization function will be relevant, and then with that problem object you need to do problem.solve and find the solution. Okay?
Okay.
Yeah. And then you'll obtain a function that is the probability of doing a backflip given parameter u, that is the number of hours of practice.
Okay, thanks.
Okay, so let's break the rooms. Let's break them in just 3.
Carlos?
Yes?
I have a problem with the installation of CVXPY.
Okay.
I'm trying to install it in Anaconda, and from the start when you present the CVXPY, it's already running and running and running, and it's not installing. And when I try to install directly in the computer, it shows an error that's a big error. What do I do?
Can you show me your error?
Share the screen.
Okay.
I can share the screen now.
Let me allow you to. Okay, so now you could do it. What? Are you sharing your screen now? Join here.
Ya está. Ahí está el otro cable.
Yeah. Sorry, I had a problem and my cell phone restarted and the camera
Sí, por un momento me
started
pidió a mí
recording.
cerrar todo lo... las salas. Em,
Okay, so can you share your screen to see the error?
I closed the error like a couple minutes ago.
Okay.
So I'm running it again. This is the third time that I start running.
Just in case I already uploaded the notebook, you can do it in Google
Yes.
Colab, and I have
In
a
Google
code to
Colab,
install.
in Google Colab, it already is installed, but in
Okay.
Conda that I use for all my programmings and all the Python files, I it can start. When I got the error, I will call you again. ¿Qué fue? Bueno. Okay.
Oh, fine. I've been changed.
Carlos?
Yes.
Bueno, si me quieres explicar tú. ¿Sabéis qué cresta es ese menor que está en el código? Nunca lo había visto en Python, en la I. Y igual random de eso.
No se te escucha nada, Carlos.
Veo tu boca moviéndose, Carlos, pero no
Carlos,
estamos
no,
escuchando tu
no te
palabra.
escuchamos. Es como ver es como ver una película muda. Te vemos mover la boca, más no escucharte.
Okay. So now, can
Yes.
you hear me now? Okay. So basically, this inequality here is you are comparing two numpy arrays, and that will give you a boolean or a number between just not between but just 0 and 1. It will give you
Okay.
0 if he cannot do a backflip and 1 if he can do a backflip. That's it.
Ok, eso tiene mucho más sentido.
Yep. You usually do this kind of stuff in an if or to obtain a boolean number.
Ok, ok. Em,
Hello. How are you guys here?
Um, yeah, having fun.
Yeah.
Basically, I was trying to find the original linear regression help. I thought it could be this, like least squared, but
Yeah, it is that one.
ah,
The hint was implying something similar to the construction of the matrix A there, in which you have a value 0, 1, and 3, but the other column is just ones.
1.
So you need to do something very similar in this case.
Okay, so we're not completely lost. We're lost, but not completely lost.
Yeah.
Okay.
But have you
so-
heard about the logistic regression before?
Yeah,
Yes.
I know in terms of what it does, but in terms of like programming it, no.
Well, here you'll program it.
Which is a problem in this course, definitely. So
Yeah, well, first try to define the easiest part, that is the variables.
yeah, so that you mean like A and B?
Yes. Here, A is already defined, so you can change it to x1 and 2, and define it as a vector in which the first component is y, the first component is A, and the second one is B.
So you mean x1.
Yeah. So first you need to import the CVX Python package.
From
Yeah, but it's without the caps. Yeah. And now you can define the variable x as cp dot variable, but you'll have two components. The first one will be A and the second one will be B. So you put variable, and inside the parentheses you put 2.
This one.
Yeah.
Okay. And
then you'll have to define the minimization function.
But do we have to do y first, or?
What do you mean with the y? Oh, the.
Oh,
Yeah, you need to do this in another cell. The first cell that I put after the instruction was where to create an example.
This one.
No. After that. Yeah. So create a new cell after the. Yeah, after that one.
You mean like here?
Yeah. So.
Here?
Okay, so all the things related with the CVX Python, put it in the second cell.
In this one. Okay, so I have to import it.
Yeah. Yeah, perfect. And
Why?
yeah, y is your data.
Yeah.
The pairs u and y is your data. No, y is just y. It's already defined in the previous cell.
Oh, okay. Yeah. So then we have to do the constraints. Is that how we?
Yeah, in this case, you don't have any constraint.
Just the objective.
Yes. Or... Yes. You just need the objective that you do with the minimize object. The first one is in capital.
Like this.
Yeah.
And then we put in here.
Here you need to.
X and Y.
No, there you need to try to write the optimization function that I wrote in the text. The one with the logarithms and stuff.
This one.
Yeah, that one.
Okay, so basically we're putting in the rule now.
You're trying to define the optimization problem. The first formula is just to explain how do you obtain the second one, okay? So you don't need to put anything with the first one. You just need to write the second one.
So min, which we already have.
It was CP minimize.
Sorry, where CP min. So we've already got the minimum at the beginning, yes. And then it's AU plus B first.
Exactly, but it's a summation. So that's what you need to think how to do.
And that's where maybe this comes in.
Exactly. You're exactly right.
So do we import least squares?
No. You need to do a matrix that is similar to the one here.
Okay, so we just import the array. Okay.
Yeah, you need to import the array. Christine, are you working as well?
I'm saying because my internet is really slow today, so if I put the Google Collab,
Okay.
it will
We don't need
close
to.
close the Zoom.
Okay, so we've got that part. So now here, do we do? Well, we've already got A up here. So it's like a lowercase a.
In this case, A would be x brackets 1 or 0 brackets 0. Yeah, but with brackets, because the first element of x is A.
So
with the square brackets.
Like,
because you're indexing the variable x.
So x
square brackets 0. Yeah.
Like that.
That would be A.
It's basically just like this. Can I even just copy and paste it like that? Or...
You can, but that's not exactly the matrix you want.
But okay, fine. I just want I sometimes I get confused with the amount of square to round bracket ratio. So it was just to help with that.
Okay.
So yeah, just and then we can change the numbers once.
Yeah, but let's first see the optimization problem. Try to write the first part, the first summation, as a matrix multiplication.
Okay. So from this one.
Do you see that you have a multiplication of a matrix that it has something with the variable u, but you're multiplying that matrix by x, that it has the a and b. So let me help a little bit, because this is not a trivial task.
Okay.
Let me.
So then that means it's not good for me if it's.
No, it's difficult for everyone. Okay. This is a difficult task to.
Thanks, you're being polite, Carlos. Okay, so just take control of the screen then.
Yeah, I'll share my screen, so you can do it.
I have to stop.
No, you don't have to stop, but okay. So I'll share my screen then. Where is it? Here. So you have an optimization problem that is the following: minimize the summation, right, of, can you, okay, of all the data in which the y variable is equal to 1. That means in our case that can do a backflip. Right? And what do you need to add up? You need to add up a times u sub I. This is our number of hours of training. Plus b. So let me write the first summation, not the second one. The second one is you need to add up something with a logarithm. Let me move this. And just the first part here, as you can already tell, if this summation was not in the data in which they can do a backflip, just a summation in all of the data, it would be something like this. You'll have u sub 1, u sub 2, u sub 3, until u sub n, 1, 1, 1, 1, dot, 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 1. And this is the part that is similar to the linear regression problem. And you are multiplying that by x1, x2. That in your code is x square bracket 0. And this one is x square bracket 1. But here is a and b. Okay? Are you getting what I'm saying now?
Yes.
Yes? Christine, are you understanding this?
Yes.
Okay, so Christine, how do you do, instead of the summation in all the data, just the summation of the people that can do a backflip? Because this only replace the summation if it was like that. But this part only adds the values when this is equal to 1. So do you have any clue how to do it? Or an intuition on how to do it? Remember that this vector here, y, is something that it has ones, zeros, in which 0 means it cannot do a backflip and 1 it means it can do a backflip. Do you know how to do it?
Well, would it not be when? Oh, sorry, it's Christine.
No, Daniel.
Would it not? Yeah.
Okay.
Would it not be that when you do the vector times the scalar,
Yeah.
when that combination is 1, then it's backflip, and then when that combination is not there, because I mean when x is when a is 0 and when b is 1. Oh, okay.
Yeah.
It's kind of. Do you see what I'm kind of trying to get at a little bit?
Yeah. That. Remember that the data is, it has a pair that has u and also y, and this is can and cannot backflip.
That has only 2 options.
Yeah.
So,
This is
I don't know
cannot do backflip, and this is hours of training. Yeah.
So why would be only 2 options? So do like a condition?
Yes, because you can or cannot do a backflip. It's not something that you can do half of backflip, or well, you can, but you will kill yourself or something like that. So basically, what you're trying to do here is just to add the terms of this summation in which y is equal to 1. This multiplication will give you
the combination of the array and the scalars. When they equal 1 or 0, that's what will determine whether they can or not.
No. Okay, so let me write this as explicitly as I can. So in this matrix multiplication will give you the following, right? Oh, sorry, this is x1, x2, and so on. And plus, oh, sorry, 1 plus x2. So this is the result of the matrix multiplication. Each of these data points or number of trainings u sub I is associated with this y, right? For example, let's suppose that the first one can do a backflip, the second one can't, and so on, and the last one can, and in between, and so on. So you only want to add this term if this number is equal to 1. This is a number that corresponds to y. And how do you do that? Well, this was a little bit hard. That's why I was trying to explain it here and not let you think it until the end of the day, because this is very difficult. Because if you want to just add the values in which y is equal to 1, sorry, you need to multiply by y transpose. What that does is that you have a lot of these terms, but as you are multiplying by 1, 0, 1, 1, 1, 0, da, 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 you can see that, for example, this one with this one will multiply, and then when y is equal to 0, it will delete this value. So in fact, if you multiply by y transpose, this expression here, you will obtain the summation only in the data points in which y is equal to 1. Mathematically, you can write this as y transpose u, this matrix u, that it has the data here and ones, and then your vector x. So that's the first term. This is just this one here. So now try to think how to do this one. It's similar to the first term. I'm not sure if that's a little bit more clear, but Esteban, can you try to talk more, maybe, to try to solve this problem? Yeah, can you help? I'll leave you this hint on how to do it, but you need to do the second term.
Carlos, how did you know to bring the transpose into this particular situation?
Because if I'm not doing the transpose, let me write the. This is a matrix that is the size of this matrix is n times 2. The size of this matrix is 2 times 1. And the size of this matrix, if you didn't have the transpose, it would be n times 1. And as you can see here, when you operate, this 1 and this n would not be compatible.
So you swap it around.
Yeah, so by doing the transpose, basically what you're doing is inverting this, and then this matrix multiplication can be compatible, and it makes sense.
Okay, yeah, that makes sense.
Yeah, you basically need to watch the inner indices, and they need to match in every matrix multiplication. For example, in this matrix multiplication here, the 2 also matches with the 2. And the resulting matrix will have this size, is 1 times n, and the other one is n times 2, and the last one is 2 times 1. And after the multiplication, this one deletes this one deletes this one, and the result would be a matrix that is 1 times 1 matrix. And basically what it means is that this is a scalar. Okay, so this is a little trick to remember how to do the dimensions of the matrix multiplication. If you want to get a scalar, you need to do this trick here, and then you can figure out where to transpose. Okay, so I'll let you work a little bit more. I'll be switching to another room. Hi.
Hi, Carlos.
Hi. You asked me to come here.
Yes.
And what is your doubt? Did you solve the first part?
No.
No?
Not yet. We're trying to use the log sum x to write the function. But there are no restrictions, right?
No, no restrictions. Can I help a little bit? I'm not sure if you already noticed this, but just to be sure, let me explain something really quick, okay?
Okay.
Because this is not a trivial task. Okay, so here you're seeing what I've already wrote. Basically what you're trying to solve is this minimization problem, in which you have a first term that has the summation only when the y sub I is equal to 1, and you also have the other one that is in all i's.
Okay.
And your data points are u sub I, that is the number of hours of training, and y sub I, that means basically if the person can or cannot do a backflip. So this y is a vector with zeros and ones, and this u is a vector with regular numbers. And to write the first part in a matrix way, to write this summation only in the y indices in which is equal to 1, you can do something similar to a linear regression. If you remember, you needed to put basically a matrix with the time points or the variable and another column with just ones. So this multiplication will give you this term, the a times u plus b. And to do a summation only in the indices in which y is equal to 1, you can multiply by this y transpose, because this will multiply like element wise here, and if it is 1 it will add this term, but if it's 0 it will not add that term. So that's the trick to write the first part. And for the second part, you'll do something similar, but with an exponential. Okay, so you'll need to do the exponential of a matrix. And as you can already guess, you have an element that is 1 and another one that is plus the exponential of something. Let me write it here. So this one is 1 plus the exponential of something. And to write this as a matrix, the exponential of a matrix, to get a 1, basically what you need is a column that is just with zeros, and the other part here. That probably, I don't remember correctly, but probably this one is this. So the function log, I don't remember exactly, some exp, what it receives is this matrix here. And it does all the operation for you. Okay, so you just need to define this matrix to put in the function, and there you're already set. Okay? No? Do you want me to repeat it again? Yeah?
One question, Carlos.
Okay.
Is that if we multiply? Oh no. Yeah. Okay. I got it. Perfect.
Okay. So that was it. But that was not your doubt, Javiera?
About the how do you proceed with the solution about minimization for the parameters A and B.
So yeah, so your parameters A and B are the variables. So you can define, for example, a vector x that has two variables, and the first one would be your A, and the second one would be your B. And what you need to do is to define the objective function by applying the cv.minimize. And your objective function, as I already told you, is something with the transpose of y times, well, in Python, the dot product is this, u, and then this, and the variable, plus the log some exp of the other thing, the other variable that I don't remember what it is, but this other matrix that you need to define. And then you need to define the problem by doing cp problem, I think. But there will not be any constraints, so you need to put something here or nothing. That's your task. And then you just do problem.solve. I'm not sure if that answers your question. Probably not.
But
right. So does the add, is that like an inner product? What is that?
Yes,
The
that's the matrix multiplication in Python.
nice. And the little prima is like a
Transpose. Mm-hmm.
Perfect. Nice.
The
Thank you.
transpose.
Can you repeat, please, the red that you write?
Okay, so
What is?
the at symbol, in Spanish,
Okay.
arroba,
Uh-huh.
as we've already seen, when you have two matrices or numpy arrays, what it means is to do the matrix multiplication. Okay, so for example, if you have a matrix 2, 1, 1, 0, and you have another one that is 1, 1, 0, 0, if you apply the matrix multiplication, here this is the identity matrix, so it will give you the same matrix.
Okay.
But if instead you used a multiply symbol in Python, that would give you the component-wise multiplication. So this is 2, this is 0, 0, 0. So in Python, if you just put the asterisk here, it will do the component-wise multiplication. But if you put the at symbol, it will do the matrix multiplication. And that little thing here is just the transpose of the matrix. This is a transpose. Yes. But in NumPy, the transpose is written like, I'm not sure if this works. You should try, but I'm completely sure that if you do .t, it works.
Yeah, I'm not sure if the matrix multiplication is an at as well. Are you sure that works for Python?
Yeah, it works for Python 3.6 and superior. If you're using the Google Colab, that should be okay.
Okay.
Yeah, that's something a little bit new about Python. It has not been around all the time. Is your question solved, Javiera?
Yes.
Yes? Okay.
Thanks.
I'll go to another room. Hello. Hello.
Hola, Carlos.
Hi.
No estoy cachando nada.
Okay.
Ya, y tu pista esta me tiene más
confundido.
Okay. Más confundido que cualquier otra cosa.
Okay, so let me share my screen. This was not an easy problem, by the way.
¿Vas a compartir tú la pantalla? ¿Te escuchas?
Okay, so let's start with the basics. With the previous cell, the first cell after the first cell after the description of the problem, we define two variables, u and y. Y is a vector with zeros and ones, or Boolean vector if you want it that way, that basically describes if someone can or cannot do a backflip, and u is the number of hours of training. And you are interested in solving this optimization problem, that is the summation of a times u, in which this is the data of the number of hours. And you also have another term.
¿Puedes subir un poco más la pantalla que está como partida hasta la mitad? O sea, me falta un poco más de arriba.
Really? And I cannot go any further than that.
Ahí está.
Okay.
No, es que me faltaba como todo lo que tienes anotado encima. Ahí está todo. Bien.
Weird. Okay, so basically the first part is to do a summation only if y is equal to 1. And the other part is to apply the log sum x function, or something like that. I don't quite remember the name. that it has as an input a matrix, and as you can see here, that matrix is related to the exponential of a matrix, but a component-wise exponentiation. Okay, so to get this one, you need to put zeros. So the exponential of this matrix component-wise, the e to the 0 will give you these ones, and the other part will give you that. Then you do the summation in that direction, and it will give you this. And then you do the logarithm, and it will do all of the other stuff for you. But that's the easy part. The hard part is how to do this summation only when y is equal to 1. And to do that, my hint was to apply what you know about the problem of the linear regression. So what I meant with that was that you have here something that is very similar to a linear regression, actually. You have a parameter a and b and a data point u. To write this summation as a matrix multiplication, basically you can put these u's in a column here, and the second part that does not have a u, you can put just ones, and then you have a variable x1 and x2 that in this case are a and b, that when multiplied will give you the correct terms in the summation. And to filter only the rows in which y is equal to 1, you can multiply by y transposed. If you multiply by y transposed, after doing the matrix multiplication, you have this, and each term will be multiplied by 1 or 0 before the summation. And this operation here, that can be summarized as y transpose u, this matrix here, x, will give you the first term. Okay? So I'm not sure if that helps you a little bit on how to do the problem.
Ok, ya estaba haciendo algo muy distinto en mi cabeza.
And if you want the code, just to be a little bit more explicit, you need to define a variable x, and it has two components. The first one will be a, the second one will be b. You need to define the minimize object with the y transpose, that is y dot t. This at symbol means the matrix multiplication with your defined matrix u and the vector x. And then you need to put the log sum x function of something. And then you define the problem and solve it. Okay?
Ok.
This is the kind of problem that will appear in the homework, probably, or something a little bit harder. So it's good practice.
Ok.
So let me finish the breakout rooms, and I'll be explaining the second part.
Perfecto.
Hello. Was that problem hard or easy?
I need to review a few things before solving.
Okay, so this is the kind of problem probably that will appear in the third homework. So I strongly suggest you, if you didn't remember some things to study, and we'll keep the tutorial. But this is the kind of problem that will be in the homework probably. Okay. Okay, so I'll share my screen again. Yeah. Oh, sorry. Where is it? Okay, so we don't have enough time, so I'll be quick about this and we'll end the tutorial. We'll continue probably in 2 days. But the second example I wanted to show is our already known least squares problem, in which you minimize this expression here. And we did it with the least squares function in NumPy, in the linear algebra part of NumPy. But now we can solve the optimization problem directly with the CVXPY package. But we will not doing exactly as the least squares problem, because if you remember, when we saw the solution of the least square problem, sorry, let me reopen this. We saw that, for example, if we have a lot of noise, the solution started exploding, or it didn't make sense at all. So that's a problem, because the weights in the least squares are getting bigger and bigger. That can be solved by an additional regularization term. That it will be the activity that I will not do today. We'll start doing it when, well, the next one, but I'm not sure when that will be. And at first, the first thing that I wanted to do, maybe we can do this one, that is just to write the least squares problem in CVX Python. And then what we will do is to add a regularization term. This is called the Tikhonov Regularization or rich regression. It depends on where did you see it. And basically we'll solve the least squares problem with this additional term. Sorry, my internet collapsed. Okay, so now what I was saying was that for the next tutorial, we'll see the Tikhonov regularization problem, in which we add this term here that is controlling the values of the weights. And also, if someone is motivated and want to do more, something that is very useful is not to do a Tikhonov regularization, but an L1 regularization. So instead of the L2 norm, you use the L1 norm, that is the summation of the absolute values. And when you do that, you'll find a relationship with the operator that we saw last tutorial, that is the soft thresholding. So I think we have a little bit of time to do the first one. So basically, let's do this one together. It should be very easy. Oops, let me add another cell. Right. Okay, so to do this, basically what you need to do is well, import CVXPY as CP. Then we define a variable that is variable of a size n. Let's say that n is a value that we have already defined. For example, 100. Then our matrix A can be defined as a NumPy array. So if we come back to this example, the matrix is defined as this one here. So we can just copy paste it. We can copy and paste the matrix A and y is the function we want to approximate. So let's just copy and paste that. And okay, CVXPY.cv, okay. Let me remove that. And let's say the standard deviation is 0.1, and that's it. We'll call this B, and we already defined everything that we needed: the matrix A, the variable X, and our data B. To define the minimization problem, we define an objective function, cp.minimize. Let's put this as 30. Okay, so minimize the norm of A times X minus B. And that's it. Yep. And the problem is cp dot problem, and this problem does not have any constraints. So if you don't have any constraints, you don't need to put anything. Just put the objective function. Okay, so this is just objective, and then problem.solve. And sorry, maybe the norm is not defined in CVP. No, let me wait. Okay, let me see something. XB minus infinity. No, that's incorrect. Maybe you need to do the summation of squares. Sorry, that is the same. Sum of squares B. I cannot see the error. Try another solver. Let me see the sizes. B.size. Well, we have some details, but all of you understands what I've done here? Nice. Yeah. Someone does not understand this formulation?
I don't understand.
Okay.
This part.
Yes, and I try to
Shape.
write the same of you and don't work.
Yeah, it's not working, but let's see. Okay, so probably this one was the problem. Name one must be string. Okay, so broadcasting dimension. Probably this is because of B. Yeah, something is a little bit weird, but we'll see it next TA. But it's better to see it next TA. But the main thing is that you can define your variables or your matrices with the NumPy arrays. This one here just represents the model of a polynomial of degree n. As you can see here, you can have a t, that is your variable, and raised to a power, so that's basically a polynomial. And in each column, you have a polynomial with a higher and higher degree. And here, your variable x represents the coefficients that is multiplying each of these polynomials. And you're basically trying to do an approximation of your data. In this case is b. That is the sign of t plus some random noise. And you just need to do it by a times x minus b. That's the part here. And probably I'm doing something wrong with the norm, and that's why it's not working. But let me check, and we'll see it in next tutorial. But Javiera, what was the part exactly you're not understanding? That why it's not working?
Yes. In my case,
Okay.
the line 9
Mm-hmm.
from CP that problem object is invalid syntax. Is my problem in my case.
With the same thing, yeah, but probably cannot broadcast. Let me.
No.
But are you talking about this exercise or the previous one?
This exercise, this last square.
Yeah, something with the solver for me is incorrect. Well, but let's see it next DA better. Okay. But the idea is that you can write an optimization problem very simply. Okay. So sorry about the problem of the least squares. Let's finish the recordings and start the other rounds of doubts.